Hello guys, this is grade 12 mathematics Ethiopian University entrance examination English part 7. Now in this part we will see the application of sequence and the series in real life. As you know, sequence and the series have many vast applications. Whether it is in physics, we will see the first question here, and also in economics, in accounting, and so on. It has a huge, vast application. Now let us begin with this particular example. This question was taken from grade 12, the previous grade 12 entrance examination. It says, a ball is thrown vertically upward from the ground to a height of 16 meters. In each bounce, it rebounds to 0.8 of the height from which it fell. Assume that the ball will never stop bouncing. What is the total vertical distance that could be covered by the ball? That is what the question says. Here, we have to neglect air resistance or air pressure. Otherwise, the ball can never fall vertically downward. It might deflect from its path if there is air pressure. Now, we assume that there is no air pressure or no external force applied to the ball except the gravitational force of attraction. Here, now, as the question tells us, a ball is thrown vertically upward. In this case, if the ball is vertically thrown upward from the ground to a certain height, let us call that height BH. Let us call that height BH. And with this rate, now it rebounds. If again the ball rebounds once it hits the ground, once it returns to the ground, it must hit the ground with a certain speed, and then it rebounds up. Now, if it rebounds up to 0.8, let us call that be R, to R of the height, the original height from which it drops, let us call that be R, R times the original height. Then what we have to do is use this formula. Use this formula. For quick answer, you need to use this formula. The total height, let us call HT, H capital T, is equal to 2 times the height to which the ball is thrown vertically upward, which is H, and 1 minus R. 1 minus R. R in this case is here. Once the ball is rebounds, then it must rebounds R times the original height, which means it reduces its height. Each time it rebounds, it reduces its height until it comes to the ground. Now, for quick action, you need to use this formula. This is very important. There is no such formula. I haven't seen so far such formula even in physics. This formula can only be obtained using series and the sequence. The application of series and the sequence. Where does this formula comes from? That is the big question. The big question is, where does this formula comes from? Let us see. Let us investigate. Here, as the question tells us, the ball is thrown vertically upward. Let us draw the path of the ball. Assume the ball is thrown from the level ground here. Suppose this is the level ground, and to this height, we throw it upward. Let us draw the level ground as such. Assume that it is horizontal. It is horizontal. And then once it is thrown to the height H, then it must return back to the ground again. It must return back to the ground due to the attraction of the gravitational force of attraction. Gravitational force of attraction. And then here it is, the path is vertical. The path is vertical. Suppose it returns back with the same height. With the same height. And then it rebounds r times this height. It rebounds upward again. Upward. Now the height to which it rebounds must be less than the original height to which it was thrown vertically upward. And again, here r times this height. Then again it returns back. This h, this height is h, and this height must be r times h. Because the question says in each bounce it rebounds r times. This is r times, our r in this case is 0.8, and r times the height from which it fell. That is what the question says. And again it rebounds. Once it hits the ground, it rebounds upward again to the height r times this one. This time it rebounds from this height. The height from which it falls is RH, and therefore it rebounds from this one, and the next h, this h must be r times this height. It becomes r times r becomes r square times h, and also it rebounds again. Assume that the ball will never stop bouncing. That is what the question says. And it rebounds up to a height r times r square times h, which is r cubed h. R cubed h. If it continues like this one, if it continues indefinitely like this one, then the total vertical height is the sum of these all heights. H, here we have twice h. The first h is the one to which the ball is thrown upward, and then the return one is also equal to h, and therefore we have 2h, and here we have 2rh, and here we have 2r square h, and here we have also 2r cubed h, and so on. Therefore the vertical height is the sum of these heights, the maximum vertical height, the total vertical height, the total. There is no, as far as I know, such thing in another field except in mathematics, series and the sequence. Here the first one is twice of this h, 2h, and once it rebounds r times the original height, the height from which it falls. That is what the question says. It must be 2r times h. Our r in this case is 0.8, and the plus. The next one is 2 times r square times h, and so on, plus, let us stop here, plus, and infinitely, let it continue like that one. And then here, if we common out 2h here, h is everywhere, 2 is also the coefficient of each of the heights, and therefore common out 2h. H is common, and the 2 is also common for all. Now what is left here? We have 1. H, 2h, once 2h is common out, it's left 1 behind. and here it will leave r behind, and also here it will leave r square behind, and so on. The next one plus r cubed, and so on. R cubed plus, now this will continue. This will continue like that one. Since in this case our r is between 1 and -1, this series must converge in that case. Moreover, it is a geometric series. It is a geometric series because when r is divided by 1, then we have r. When r square is divided by r, it is also r. When r cubed is divided by r square, and again it is r, then the ratio of any successive terms is constant. In that case, this is a geometric series. And in geometric series, we know that let us say if the geometric series converges, then it must converge to the first term, which is known as G1, over 1 minus the common ratio. That is what we have seen. And therefore, here in this case, our first term is 1, and our common ratio is r, and it is nothing but 2h, the total height, the total vertical distance or height that is covered by the ball should be given by 2h times 1 over 1 minus r. 1 minus r. Now we have every variable in this case. We have h, we have r, and therefore simply substitute those numbers for the indicated variables. Here is 2h over 1 minus r. It is the same to the one we already write here. And here simply use the height. Our h in this case, our h is 16. Our h is 16 meter, 1/6. And our r is 0.8. Our r here is 0.8. It is given. And substitute these values for the two variables there. Then you will get the maximum, the total distance that was covered by the ball. It is equal to, ht is equal to 2 times, our h is 16, just put it in bracket, 16 meter, over 1 minus 0.8, which is equal to, again, this becomes 2 times 16 is 32. We will add meter later on, over the difference of 1 and 0.8 is 0.2. And simply add 0 here. It becomes 320 over 2 meter. This is simply 2 meter. When 320 meter is divided by 2, it becomes 160 meter. 160 meters. That is the total vertical height. The total vertical height that is covered by the ball. If the ball is thrown vertically upward to a height h, and again in each bounce if it rebounds to r times of the height from which it falls from now on use this one, and therefore our answer is 160 meters. Here I actually did the same thing using on computer again. Here you can see that our h is equal to 60 meters and r is equal to 0.8, and then the sum of the total the total distance that is covered by the ball is 2h plus 2hr plus 2hr. Noting that the ball covers, each time the ball is thrown upward, it covers two times of the height to which it is thrown, and therefore now the entire formula gives us this one, which is similar to the previous one, and then our answer is 160 meters. Let us come to question number 2. It is similar but a little bit different. In that case, in the next question, the ball is simply dropped from a certain height. Let us see the next question. Question 22 says, suppose a ball dropped from a height of 60 meters and always rebounds to 3/4 of the height from which it falls. What is the total vertical distance that could be covered by the ball, neglecting air resistance again? Assume that the ball will never stop bouncing. That is what the question says. This is different from the previous question. The previous question deals with when the ball is thrown upward, and in this case, when the ball is simply dropped. Dropped means there is no initial velocity in this case, but it is simply, the ball is simply released from a certain height. Here our h, given our h is the distance, the height from which the ball falls is 60 meters, and our r in this case is the rate at which the ball is rebounded each time is 3/4, as you can see, 3/4 times the distance from which it falls. And in this case, to make it short, the easiest way, if this kind of question appears on the examination, use this formula, the shortcut. H total, the question says what is the total vertical distance that could be covered by the ball, and therefore let us call this is the total vertical height. This is equal to, put it like this, open the bracket, 1 plus r over 1 minus r times the height to which the ball is the height from which the ball is dropped. Here is h. Use this one, use this formula, but you need to remember this one, or else you need to drive the formula to get. Assume that you just suddenly forget this formula. What would you do if you don't know how to drive this formula? You don't know nothing, and therefore you will miss this question, and therefore you need to know how to drive this formula. From where this formula comes from, you have to know that. Let us see. Here the question says the ball is dropped from a certain height. Let us call this one B. H, it drops to H height, from H height. Let us put H here, and it rebounds. Once it hits the ground, then it rebounds up to the distance, 3/4 of the distance from which it falls. It means here r times h, similar to the previous one. r times h. And again, it rebounds from this height to r times this height, r square. It becomes r square times h. And the process will continue like this one. It continue like this one. It continue like this one. Note that when we say vertical, it dropped vertical. Here, this h, we don't need to draw like this one. This is projectile, but it's simply on this path. The rebound will take place in this path. And then, what is our h? Sum up this one. If this continue like this one, sum up. Our h total is going to be first, it's dropped from h, therefore write 1h. And the next, once it rebounds, the path is going to be twice. The path is going to be twice. And therefore, we have 2RH. And next also, we have 2RH square, R square H. 2 times R square H. The process is actually the same to that one, except the formula. Now, if it continue like this one, then what we can do is just leave H here, and but for this part, the common factor is 2h, and therefore common out the common factors 2h. And open the bracket. Here we have r, and we have r square. The next term is r square, and the next term is also r cubed, and so on, and so on. We don't need to write, just put it like that one. Now observe that the sum r plus r square plus r cubed plus and so on forms a geometric series. A geometric series. Since our r, as you can see here, is between 1 minus 1 and the 1, then this series must converge. In this case, our first term is r, and our common ratio is r also. And therefore, here h plus, the formula is the same as the previous one, the formula of geometric series, converging geometric series I mean. Then put it r, the first term, over 1 minus the common ratio. The common ratio is also r. And multiply the numerators. Multiply the numerators, then you will get h plus 2hr over 1 minus r. Now take the least common multiple of the two. Here we have h over 1. We have h over 1. Multiply this one by this and the 1 by 2hr. You will get the following. Here, when we multiply this by h, it becomes h into 1 minus r plus 1 times 2hr becomes 2hr over again. Multiply this one. 1 minus r by 1, we have 1 minus r. and again multiply h by 1, it becomes h. Multiply h by minus r, we have minus hr, and here we have also plus 2hr, over the total here over 1 minus r. Now add or subtract similar terms from one another, which means in this case similar terms are hr, this hr plus 2hr are similar terms, and therefore from 2hr if we subtract 1hr, then the result is only 1hr, and we have h plus hr here, h times r here, over 1 minus r. And now observe the expression on the numerator. H is common for both. Here we have h, here we have h. Common out h. When h is common out, it leaves behind 1 here, 1 plus r over 1 minus r multiplied by h, because we common out h. That is the formula. That is the total vertical height. There is no way you can find such a formula in physics, as far as I know. As far as I know, there is no such thing. This, if there is, again, if there is, that field or that formula comes from sequence and the series, unless and otherwise we apply integration, calculus to sum up this one, and that is what we get. That is what we get. Now here our variables h and r are given here, and therefore replace them by here insert each of this one in respective variables. Here we have 1 plus 3 over 4. Our r is 3 over 4. 3 over 4. It is already done. Let me show you here. Why should I take your time? Here our h is given. Our h is given. It is set 60. Therefore 1 plus 3 over 4. Now here 1 plus r means 1 plus 3 over 4 over 1 minus r means 1 minus 3 over 4. Our r is 3 over 4 times h. Our h in this case is 60, and therefore the sum of 1 plus 3 over 4 gives us 7 over 4, and the difference of 1 and 3 over 4 is going to be 1 over 4. Cancel 4 and 4, then only we have 7 here. When 60 is multiplied by 7, then it gives us 420 meters. Therefore, the total distance that could be covered by the ball in this case is 420 meters. That is the total vertical distance. Now here, next time, in the next part, we will see there are also some application of sequence and the series. We are now about to complete the chapter 1. I mean chapter 1. Here you can see a number of such examples here. Then for today, let me leave you with this one. Till then, have a good time. The presenter for today lecture is Umar Adam, and have a nice time. Goodbye.